Alright, what's up, Algebra 1 and Algebra 2 kids? This is for the second assignment, Systems of Equations. I think it just says Elimination and Substitution at the top because that's what we're doing. Remember, when we use elimination and substitution, we're not talking about just one equation anymore. We're talking about two at the same time. So we're trying to find an answer. Get text over here. We're trying to find an answer that is some number x comma y, right? Because there's an x and a y in our problem. We're trying to find some answer that actually, when we plug it in, satisfies both equations. So when I plug a 2 in for the x and a 4 in for the y into the actual equation, do I get true statements? That's what I'm trying to figure out here. Okay. For you Algebra 2 kids, there's some ACT problems attached to the end of it, and I may make another video for those because we haven't done a lot of word problems. Okay, we were going to do a lot more whenever it came ACT time. So we'll see what I do there, but a few application ACT problems there at the end. So elimination is the first thing we're going to cover, and I have the steps over here to the right. The first thing that I tell you guys to do when I taught you was we're going to multiply the top equation by whatever number is in front of x in the bottom equation. In this case, that's a 5. Right? That's what's right there. And then I tell you guys to multiply the bottom equation by whatever number is in front of x in the top, but opposite sign. Right? So I'm going to multiply the entire bottom equation by -3. All right, and make sure you're multiplying the entire equation by that number. So this 5's got to go to all three of these guys, which creates 15x minus 10y equals 10. And the bottom, I get negative 15x plus 15y equals negative 30. Make sure you're multiplying correctly. Now, my first two steps that I give you over here, those are not the end all be all. You have to do it that way. Okay, that's just the way I've taught it. Okay, so that all of us are doing the same thing. But now's a good time because you may look at another video and see it done a different way. When you're doing elimination, you're just trying to get the x's or the y's to eliminate when you add these two equations together. So like right now, I'm about to add these two equations together. And when I do that, the x's are going to eliminate. All right? They're going to cancel each other out. And I'm going to add my y's together. So negative 10 plus 15 is 5y. And then 10 plus a negative 30. All right, you get a negative 20. So the point of that is to get rid of one of the variables. Now, the way I taught you will always get rid of the x. Right? But it doesn't have to be that way. Again, if you look at other videos, they may get rid of the y to start, and that's completely fine. All right? But you can see that our goal is to get, let's see if I can erase this one thing without messing everything up. Your goal is to get the x's or the y's to be the same number opposite side, because that's how you get things to cancel out, right? One's got to be a positive 15, one's got to be a negative. When I add those together, they're gone, right? So you can do it with the y's. I could have multiplied this top equation by the number that's in front of y. And I could have multiplied the bottom equation by this number, but I would have still had to change it, okay? And it still would have worked. Okay, so if you look at another video, they may do it a different way, okay? And that way is fine too, if you understand that way and if you like that way. But the way I teach it is this way. You're going to multiply the top equation by the bottom x, so in this case, the 5. And I'm going to multiply the bottom equation by the top x, this 3, but you got to change it. Again, I change it so that no matter what, the signs are going to be opposite right here when I add them together. And then this is an easy equation here at the end to solve. I got 5y equals negative 20. I divide by 5. Y equals negative 4. Now we're not done though. Okay? I need to take that answer. All right, we're past step 3 now. We've already solved for y. We did that. I need to plug my answer back in, okay, into one of the original equations. So it doesn't matter which one. I can pick this one or this one. I'm going to pick the bottom one because the numbers are smaller. So I'm going to go to that equation and I'm going to plug in my answer for the y. So I plug in a -4 where that y used to be. So -2 times -4 is a +8. And then I just continue to solve this equation. I subtract the 8 to the other side. And then I divide by 3. So I get x equals -2. So my answer is -2, -4. Remember, we write our answer as x, y. Okay? So again, these are the steps to the right. Multiply the top equation by the bottom x. In this case, it was a 5. I multiplied the bottom equation by the top x, which was 3. But again, I had to change it to a -3. When I add the two equations that I just created together, my x's eliminate. That's why it's called elimination. And then I solve for y. And then I take that answer and plug it back into one of the original equations and solve it for x. And that's how we did elimination. Okay? We also had substitution, another way of solving them. Okay? You're still the same type of problems. We got two equations. We got an x and a y. Also, it won't always be x's and y's. It could be a's and b's, c's and d's. It doesn't matter. Okay? We're just used to using x's and y's. In substitution, the thing that's going to be different, and when you know you're going to use substitution, besides the fact that, when I tell you to use it, is one of these variables is not going to have a leading coefficient, meaning it's not going to have a number in front of it. And that's going to be this x right here, right? That x does not have a number in front of it. So my first thing is to get this guy all by himself. So if I want him all by himself, then I need to move the 3y to the other side. So I'm going to add it over. So this equation is now x equals 3y minus 6. Again, put your variable first, 3y, and then the minus 6. All right, so now what you're going to do is you have a new equation. You created this guy. And it says that x equals 3y minus 6. So what that means is I can take this 3y minus 6, and I can go to the equation that we haven't touched, and I can put him in the same spot as this y. Sorry, I almost messed it up. I can put him in the same spot as this x. Now, why am I allowed to do that? Well, because x and 3y minus 6 mean the exact same thing. Obviously, they don't look like the exact same thing. But they're equal. Our equation says they're equal. So, wherever I see an x, I can take it out and put 3y minus 6 instead. Now, we do that because if you look at this equation we have now, it just has y's in it. We know how to solve an equation that just has one variable. We've been doing that since 8th grade. Okay? What we can't do, we can't solve an equation that has two variables. Okay? So what we did here is we took x and we found something else that was equal to it and plugged it in. We substituted it in. So now I have just one big equation that has a bunch of y's in it, which we know how to solve. We're going to distribute. We're going to combine my terms. I have a -12y and a +9y. Well, that's -3y. It's a really bad 9. Okay, and now I'm going to move my numbers to the right. So I'm going to subtract this 24. And then I'm going to divide by this negative 3. And that gets me an answer of y equals 5. Okay, but just like in elimination, I'm not done, right? I only have half my answer. I have a y. I need to have an x as well. So I'm going to take this answer, and I'm going to plug it back into one of the original equations. But not actually the original equations. We're going to plug it into the equation that we made. This guy right here. So the equation we made was x equals 3y minus 6. But we know that y is actually a 5. Again, we're allowed to do that because we know that y is 5. So those two things can flip-flop spots. They can substitute in for each other. So when I do that, I get 3 times 5, which is 15. I subtract 6, and in the end, I get x equals 9. So my answer is 9, 5. Okay, so these were the two ways that we learned how to do systems of equations. We learned elimination, okay, where we got one of the variables to eliminate. Or we had substitution, where we took our answer, or one of our equations, which is this one right here, and I substituted it in to the other equation. And what that does is it gives us an equation that only has one variable. We only had y's, because we can't solve an equation that has two different variables. So we have elimination and substitution. Again, if you guys have questions, email me, text me. Again, if you look up other videos or if you look up other help, they may do it slightly different. The substitution should be the exact same. There's no other real way to do substitution. Elimination, you could get something that's a little bit different, but if you like it and you understand it, it's going to get you the same answer that we got. Okay, it's just another way of doing it. All right, so email me, text me if you have any problems. Algebra 2 kids, I might put up a little second video for the ACT problems, just to kind of give you an idea of how you need to attack those. But, yeah, that's it. Hope you guys are doing well. And I'll see you soon, hopefully.